again. Another wonderful, wonderful night spent with my favorite students in the entire world. And Bailey. All right, kids. Here we go. Unit 5 review. I think there's like 20. Let's take a look. What do we got? Where'd my mouse go? 26 questions. I'm not sure how long this is going to take, but we're going to get through these. We're going to get started. Make sure that you've done the problem before you watch me do the problem. I'm not a performing monkey for you. All right? You don't see me with my... like that commercial with that guy with the hairy armpits. Can you see my arms, by the way? Hairy armpits, you know? No, I am not a performing monkey for you. So, in order for this to actually work, what you're going to want to make sure that you do is do the problems before you watch the video. And then, perhaps, if you don't understand, then you can check the videos out. So, I have a hard time finding my mouse. Oh, there it is. So, got them blown up. Here we go. That's a little bit too much. I think that's going to be behind my head because I got a big old head. These lights shining off it make it look real pretty. I know you guys are worried about that. All right, I'm up there. Okay, so first things first. We are going to draw parentheses around everything. Now, this is a division problem. All I'm being asked to do is simplify it, okay? So remember, you are not allowed to cancel anything out that's got adding and subtracting. Plus, I have this division problem right here. That means I need to turn it into a multiplication problem, and that's what we're going to do right over here. That is an amazingly straight line, and that, not so much. Whatever. So, I'll start with the easy ones. I've lost track of my mouse because it's too small, so let me see if I can go to a bigger one. All right, there we go. That's bigger. I can actually see it. Okay, this 36 comes first, so the 6 comes first. So 6 plus x, 6 minus x. This one's done. All right, let's talk about this bottom one. That's pretty easy. Both pluses have to add up to 12. Add up to 8, multiply to 12. If you product some things, it's the same thing. So x and x plus 2 and plus 6. Over here, check. Now we're going to do this one. Take out a GCF of x, and I'm left with x minus 6. What do you think? Huh? Is that okay? Are you guys following along? Or do you think I made a mistake? Oh, then you'd be right. I made a mistake. Don't get caught up just automatically starting to type stuff in, right? Take a look, see what you're doing. This has to go into the denominator. Remember, it's a division problem that we turned into a multiplication problem. In order to do so, that second fraction must get flipped. So, what we're going to do is take out an x, but it is x minus 6 down here, not above. Ooh, got an itchy eye. And this one, absolutely nothing to do with x minus 2. It's just x minus 2. So I'll take out another color just for fun, and we'll start crossing stuff off. Let's see. This x plus 6 cancels with this x plus 6. Now, this x minus 6 and this x minus 6, now they divide out, but remember, they make -1, not +1. So they divide out. So, and these can't be canceled. It's x minus 2 and x plus 2. That's just what it is. So my final answer is negative x minus 2 all over positive x plus 2. Now, should I happen to, in that rare case, make a mistake, you get bonus for being the first to text me or email me and let me know that I've made a mistake. Now, I know it's rare. Don't make mistakes very often, but it's late, I'm tired, I'm old, and yes, I'm bald. Careful. Okay, here we go. I have no idea where my mouse pointer went. Oh, there I am. Okay, so, okay. Parentheses. Put parentheses around everything so you don't make dumb... What in the world went there? I'm going to guess this was a b squared. Something happened in the translation, so I'm guessing it's b squared. I'm hoping it is. Based on what's around it, if it doesn't work out, I've got the notes next to me. I can check it out. All right, I'm starting easy. This one's easy. It's just a minus b. Notice no flipping this time because it's just multiplication. sound like I'm on the TV with some major drama gonna happen. Man, I should have gone into TV and broadcasting. I'm going to take out an A. I'm left with A plus B. These do not cancel. Don't be stupid. All right. So this is the one that you all probably dread, this A to the fourth. A to the fourth is so difficult. We'll make it A squared minus B squared. A squared plus B squared. I think I'm going to have to get used to the smaller print because this stuff's way too big. I'm going to find this little dot floating around. Now this can be factored. This right here can be factored too. Yes, you guessed it. God, I teach smart kids. A plus B, A minus B. And we're almost done. Wow, this one's really bad. Oh my goodness. Come on, guys. Take your cues from what's there. A and A. Multiply to B squared. Well, the only way to multiply to B squared is B times B. They have to multiply to positive B squared and add up to negative 2. That just means they both have to be negative. All right, factoring's done. Now it's time to take out the red pen. Don't get scared, kids. I'm just canceling common factors out. I'm not marking your papers wrong. All right, some of you got a little teary there. All right, let's see. This A minus B cancels with that A minus B. This A minus B cancels that A minus B. This A plus B cancels with that A plus B. And I believe, if I'm correct, I'm left with A squared plus B squared all over A. Now notice I cannot cancel this A and this A squared. These things, this is it. This is my final answer. You can't cancel the A because it's A squared because it's in parentheses. Don't do it. You'll get beat up. Not by me. I don't hurt students. Well, maybe I do. Or maybe I don't. Haven't decided yet. Oh my God, 3 fractions. The F word 3 times. Parentheses, 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 parentheses. Alert, 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 alert. God, am I a nerd or what? Okay, but seriously, that's backwards. Got to be paying attention to it. That's an alert. Also, division. Make sure that you don't do anything stupid. Parentheses, 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 parentheses. But Mr. Krause, that's got a 2x. I can't factor that. I don't like to factor. Don't care. Suck it up. Man up. Woman up. I don't care what. All right, let's go to town. This one's easy. We're going to do this one over here last. We'll do that last because it's going to be the hardest. It's so difficult. This one, take out a 4. I'm left with x plus 2. This one, x plus 1. This one, I'm going to leave it as 2 minus x. That's okay. This one, I can take out a 3. I'm left with x minus 5. And hold on a second. I think there's a number missing on this one. I'm going to have to keep my track of my 2x squared minus 8x. Wow, this thing really translated bad. I knew that 1 was a problem. All right, that's actually supposed to be a 10 there. So I'm going to have my notes next to me. And I can cheat when I need to. Just kidding. I don't cheat. Never have, never will. Plus 2, minus 2. Okay. And finally, I got to factor this thing. Well, I'm looking at it now that the 10's here, and I'm thinking, well, there's a GCF. I'll take the GCF out. Thank goodness. X squared minus 4x minus 5. But I'm not done. I can still factor that. So I'm going to put 2 and then 2 sets of parentheses, x and x. Let's see. How about minus 5 and plus 1? And we no longer have this. All right, take out the different colored pen. Just because it's so much fun, we'll go green. A little Christmas. Merry Christmas. All right, moving on. This x plus 2 cancels with this x plus 2. This x minus 5 cancels with this x minus 5. This x plus 1 way over here cancels with this x plus 1 way over there. And then I also have this 2 minus x and this x minus 2. Remember, we set our alert because this is going to be the -1 rule. Don't screw up. And I believe I've canceled everything I possibly can. In the numerator, I have -8. In the denominator, I have 3. I don't think I missed anything there. Hopefully not. Okay, I think that's the last problem on that page. We'll slide over and up. Now I know there was a tailor, can't remember which tailor, they're all annoying anyway, but one of the annoying tailors told me my big bald head was in the way. So hopefully when I put my big bald head in this problem that you can actually see. Let me make this a little bit smaller, make sure it's off to the left. I like to have my big bald head right in the middle, off in this corner over here. So let's see. All right, now we're to adding and subtracting, which you can do very easily, I hope. Okay, so, okay. How many times have I said okay? You should count. Maybe there's bonus for the number of times I've said okay. But if you actually count them, I won't know the number. You can lie to me, and I still won't believe you. Okay, common denominator. Well, in this case, I'm going to rewrite this. I'm going to show you something. This one is 2 minus x, or excuse me, 2 minus 6x. And I'm going to put this 3x here. Now, there's a reason I'm doing this. I could factor that denominator. But I looked at this, and I'm thinking, wow, that looks backwards. I'm willing to bet I can just turn that around. Remember, we've talked about that. Turn that around. But in order to do so, you have to factor out a negative, and we put it in the numerator. So, negative 9. Now, I turned this around, and I took out a negative. We've talked about how to do that in class. Well, now I have a common denominator. So my numerator is going to be, now I can just add 3x minus 9 all over 2x minus 6. But don't stop there. Oh, no. There's so much more fun to be had. Really? Seriously? Crowds get a life. Take out a... Oh, man. Embarrassing. At least I caught myself. We're going to take out a 3, and I'm left with x minus 3. All right, I picked the big fat pen. Don't want the big fat pen. I want the skinny pen. And in the denominator, I can take out a 2, and I get x minus 3 as well. So those cancel. My actual final answer here is 3 halves. So the whole thing just turned into 3 halves. That's so cool. All right. So don't make that classic blunder on these. Remember, x plus 3 is a thing all by itself. So we're going to take that. So our common denominator here is going to be x, this one, the thing from here, and x plus 3. X plus 3. Now, in order to do so, this one got multiplied by x plus 3. So 1 times x plus 3 is x plus 3. This one got multiplied by x, so plus x. So almost all said and done. I can now add. I get 2x plus 3 all over x times x plus 3. Now remember, those 3's cannot cancel because that 3 is in parentheses and it can't cancel with the 3 that's in the numerator. Please don't do that. Oh my goodness, nothing makes me more mad than that. All right, remember, we got a problem here. We got this minus right here, this minus. Okay, and we're going to eliminate it right away. Remember that. Please don't make that mistake too. We're going to make this a plus by moving up that minus right there. Usually just... Now, is it necessary? No. Is it going to make your life easier? Usually. All right, let's factor this denominator. X plus 1, x minus 1. And this is going to be just x plus 1. All right, so my common denominator, once again, not once again, for the first time today, is x plus 1, x minus 1, plus x plus 1, x minus 1. Now, this first fraction, I didn't have anything to do with the denominator. I didn't change the number. I factored it, but it hasn't changed. So because that hasn't changed, the numerator doesn't change. It remains 3x plus 1. However, this one, the denominator, I had to multiply by x minus 1, so I also have to multiply the numerator x minus 1. Well, remember, we're going to distribute a negative. So I get negative x and then plus 1. So negative x plus 1. All right, there's going to be some magic happening. In the numerator, it's 3x minus x equals 2x. And 1 plus 1 is, well, 2. all over x plus 1, x minus 1. Now, if you get this far, give yourself a hand. That's enough, because you didn't deserve it all, because you didn't realize that the numerator can be factored. Take out a 2. I'm left with x plus 1 all over x plus 1, x minus 1. And finally, notice these cancel. And my final answer is, wait, what the heck is that thing? My final answer is 2 over x minus 1. I think for the next problem, I'm going to talk like I'm a reporter on TV reporting on some news. You guys tell me how I do. Let me know. Let me know if I should just give up this teaching gig and go right into being a weather forecaster. I'm thinking I can do it. So, students, here I find myself at the brink of doing this problem. I think I can handle it. But first, I was told to put parentheses around everything. So that's what I'm going to do. All right. I don't really think I can do that. That's kind of annoying. Holy mackerel. Lots of stuff. All right, let's try our factoring here. This is going to be a minus 3, a minus 2. Now, I'm not going through how to factor these things. I hope at this point in your life you can do this. This is a minus 3, a minus 4, and this is a minus 2, a minus 4. So, you know, because this problem is so long, I'm going to kind of simplify things a little bit. I'm only going to do this denominator once. A minus 3. I have no idea why I made that line that long. Oh, it's getting late. It's like, hold on, let me check. 7:30. Oh my gosh, I'm getting tired. That's because I'm old. I know you guys are saying, no, Mr. Krause, you're not old. You're young. And you're, oh, I got the green. You're young. You're not old. All right, so this is missing an a minus 4. So we're going to multiply by a minus 4 here. And I'm not going through the double distributing, but I'm going to do it. A squared, trying to make my a's not look like 9s. Minus 4a and plus 2a is minus 2a, minus 8. This one is missing, let's see, we got the a minus 3, we got the a minus 4, but it's missing the a minus 2. So, plus a squared. Now this is, did you notice that these are a conjugate pair? These are conjugates. So I don't need to do the entire double distributing. I realize the middles are just going to drop out and I get a squared minus 4. I'm so smart. And this one's missing the a minus 3. So 1 times a minus 3 is just a minus 3. Remember to have a pencil for the test. Remember, I'm a pencil fanatic now. I'm going to be a crazy man. I'm so tired of getting crappy work. You should see some of the work I get. I'm going to make a copy of somebody's tomorrow, and we're going to just laugh at it and have fun with it. Sorry for the person that I'm going to make fun of. I really do like you as a student. Or maybe not. This is Mr. Krause, reporting here from my basement, freezing my feet off. No, I'm just kidding. I'm okay. Okay, guys, don't worry about me. I'm good. 2a squared. A squared gone. I'm going to go minus a. Minus a. And then minus 8, minus 3, minus 4. Man, that's a lot of minusing. Let's see. That's going to be negative 15. That's what I'm going with. And just because I think that there's a possibility that this might be factorable, I'm going to check it, actually. And I taught you guys the other day how to check it. All right, you're going to do the discriminant. If you remember correctly, I got to find some room. B squared minus 4ac. Now I'm going to do this using my brain. Doesn't grow hair anymore, so it's only used for mathematics. B squared is, well, 1 minus 4 times 2 times 15. Oh, negative 15. Let me squeeze in a negative. Well, that's 8 times 15. I'm a math teacher. I know that's 120. Positive 120 plus 1 is 121. And since 121, we all know to be a perfect square, this is a factorable quadratic. So as soon as I find my mouse, I am going to factor 2a and a. Now, if I'm a guessing man, I see an a minus 3 down here. That's the only factors of 15 are 5 and 3. I'm guessing this one's going to be a minus 3. That would mean this one has to be positive 5. Let's check it out. Negative 6, positive 5. Lo and behold, they do, in fact, add up to that middle number 1. I'm grabbing the fat red just because I'm in the mood. Those cancel. So my final answer is 2a plus 5. In parentheses. Don't take it out of the parentheses. Over a minus 2. A minus 4. Yay! Page 1, done. We're like 1/4 of the way through. You know why they call these complex fractions? Because they're really complex. Just kidding. Let me move back to skinny. It's hard to see where I'm pointing, I understand, but as far as writing goes, it makes it much more easy. Makes more easier. Easiest? I don't know. Good English. Lowest common denominator in this case is x times y. So I'm going to put an xy next to each of these. Xy and xy. And then I'm going to start canceling out common factors. Now you're allowed to do that because I'm multiplying the numerator times xy. I'm multiplying the denominator times xy. So it's not a problem. This y cancels with this. Why did I cancel the x? Okay. It cancels with this y. It leaves me the x, which I'm going to distribute. No, I'm not. Yes, I am. No, I'm not. No, I'm not. I'm just going to leave it. It's going to be x times x minus y. I'm not sure why. I'm just thinking I'm going to have to factor later anyway. Let's see what goes on here. Now, this y cancels with this y, leaves me x minus. And this x cancels with this x, leaves me y. Oh, look at that. The Krauss man was right. Oh, my God. Sometimes I amaze myself. The answer is x. Is that right? Is that right? I'm not sure. That seems wrong. That seems so wrong. Is it just x? Oh, I don't have the answer key to this one. I'm going to guess that's right. But again, should I happen to make a mistake and you correct it, and you were the first to tell me about it, bonus for you. All right, here we go. No, I didn't pick my nose. Leave me alone. All right. Ouch. How are we going to do this one? This one I'm going to rewrite. This is n over 1 minus 1 over n all over I think I've written this problem down wrong. Let me take a look at it for a minute. I'm not ignoring you. You blinked first. Maybe. I'm just checking this out. Yeah, I wrote this problem down wrong. I'm going to fix it. I'll fix it before I give it to you guys. So when you guys get it, it's going to look a little bit differently. I'm pretty sure this is wrong. Let me rewrite this the way I think it's supposed to be written. Hopefully this will work. If it doesn't work, I'll blame somebody. I believe it's supposed to be written like this. I think I extended the wrong fraction line. I think it's supposed to be 1 over n minus 1 all over 1 minus n squared over n. And I know I created an answer key, but when I went back to make it look nicer, I think I screwed up. So I'm going to put this over 1. So my common denominator is n. So I'm going to multiply everything through by n. I'm going to multiply this by n. I'm going to multiply this by n. And I'm going to multiply this whole thing by n. And I believe this is going to work out nicely, but we'll see in a second. So in this case, nothing cancels here, so I'm left with n squared. In this case, I get minus 1. All over, in this case, the n's cancel, and I'm left with 1 minus n squared. Well, what do you notice? Aren't these things just backwards of each other? They're completely backwards of each other, so we know that these can cancel, but they make negative 1. So that turned out to be a pretty simple problem. All right, sorry about that. I'll fix that. before you get it. So you won't even notice it until you get to the video. And you'll be like, wow, Kraus made another mistake. What an idiot. I can't believe I had an idiot for a teacher. Thought I had a smart guy, but not anymore. Common denominator between 2D, D, and 2 and D is, well, 2D. So I'm going to multiply everything through by 2D. 2D or not to D. 2D, 2D. Bust out the red pen. Oh, yeah, I can bust out the red pen. I'm so damn cool. I said the D word. Shh, don't tell anybody. The 2's cancel. I'm left with D minus. Oh, I should have changed that to a minus and a plus there. Didn't do that. This D cancels with this D, leaves me minus 8. All over. This D cancels with this D and leaves me 2. And this D cancels with this 2D. It leaves me plus 3. Well, that's weird. So I'm just end up with, looks like D minus 8 over 5. And that's the correct answer. Nice work if you got it. Bad work if you didn't get it. Moving on. Here we go. On to number 11. All right, now we're solving, right? So what we want to do now is we want to get rid of the fact that all fractions. We don't like fractions. They're the F word. One of the few F words you're allowed to use in class. Fun is the most important word. All right, so let's find out. This one we're going to have to factor. And we're going to factor to x times x plus 1. So it should be obvious that my common denominator is x plus 1. So x times, what in the heck just happened? I think I had my finger on the thing. X plus 1. Uh-oh, Kraus, man, you failed to distribute that negative. Put this in parentheses. Put this in parentheses. We're going to multiply this one times x plus 1. And this one we're going to multiply x times x plus 1. Man, I'm brutally crushing this problem. And that, by crushing, I mean like totally screwing it up. All right, so let's see. This x plus 1 down here will cancel with this x plus 1. Let's see if I can manage to pull it out and get it right. 3x squared. Now this one's going to be tricky. No, it's not really. A little bit tricky. This x cancels with that x. And I have to double distribute. Now be careful. This is a negative x squared plus 8. So we're going to get negative x squared. This is a negative x times positive x. Now it's negative x times 1 and positive 8x times x. So that's plus 7x plus 8 equals. Now here, this cancels this. It just leaves me 5x squared plus 2. Now I actually wrote this problem today. It took me forever to write this problem. I don't know. Had a brain cramp. All right, so everything has got to come to the right side, but let me clean up a little bit here. This is 2x squared plus 7x. Now, if this problem doesn't work out, I'm going to be really mad. Equals 5x squared plus 2. Everything's going to come to the right side. And we're going to end up with 0 equals 3x squared minus 7x minus 6. Somehow that doesn't work right, but hopefully it does. 3x and x. Now I know I can't put a 3 with this one, so I'm going to put the 3 over here and the 2 here. Ah, this works. 9 and 2 can make 7, so we're going to do minus 3 and plus 2. These two make negative 9, and these two make positive 7, and that adds up to negative 9. So my two answers are x equals 3 and x equals negative 2 over 3. Now, don't forget, on these, you must come back up here and say, okay, x cannot equal 0 and negative 1. So since neither of my answers turned out to be that, I'm good to go. All right, let's see if I can not butcher this one. I'm going to go to red. Not fat red, skinny red. First things first. Change it to a plus sign. Shades those over. Get everything that's being added, subtracted, put it in parentheses so you don't make dumb mistakes. Now this one needs to be factored. X. Oh, I didn't pick my nose. Minus 4 x plus 2. And lo and behold, that's what these are. So that's my common denominator, x plus 4 and x plus 2. So I'm going to write that. Let me grab a different color. I'm going to grab blue just because I'm thinking a little festive. X plus 2, x minus 4. X plus 2, x minus 4. And then x plus 2, x minus 4. All right, so on this one, over here, the x plus 2's cancel, and I'm left with negative 3 times x minus 4. I'm just going to show you that work just to make sure you got it. And then these x minus 4's cancel, and I'm left with plus negative 2x plus 5 times x plus 2 equals, and this just cancels with all of this. So it leaves me just 20x plus 2. All right, so I get negative 3x plus 12 minus x squared minus 4 and plus 5 is plus x plus 10 equals 20x plus 2. I haven't looked up at you guys in a while. Were you thinking I was just staring at the screen and not worried about you guys? I care about you guys, man. I really do. I want you to do well. So work hard. Stop listening to me. I mean, keep listening to me. Whatever. All right, let's clean up this left side. It's a mess. X squared minus 2x plus 22 equals 20x plus 2. Do you see how I was watching and writing? Nice. Everything's got to come to the left side, so we need the right side. So we get 0 equals x squared plus 22x minus Oh, I knew there was a mistake. Somebody should have caught it. This should be minus. Whoa. Yeah, this should be minus 2x. So this would be minus 2x, and this would be plus 2x. Caught it! Thought you were gonna get me! I found my mistake! Okay, whatever. I'm a loser. Shouldn't have made the mistake. Freaking professional here. Minus 20. Let's go with that. 0 equals, take out a 2, I'm left with x squared plus 11x. How many of you all immediately, as soon as I made a mistake, like, oh, I got to text Mr. Krause, oh, you made a mistake, and then now you're looking like an idiot. I'm glad you found the mistake, though. Maybe if you're first, I'll still give you a bonus. No, just kidding. But I'm glad you found it, if you found it. Minus 10. All right, factoring here, it's kind of easy. X. All right, I thought it was going to be easy, but I made another dumb mistake somewhere. Someone find it. Oh, my gosh. What mistake did I make? Plus 10. That's plus 12. That's 22. Bring the 22 over. Put it with that. You get minus 10. Minus 3x plus 12. When I distribute these two, I get negative 2x squared minus 4 plus 5, that's negative x, plus 10. That's 22. Subtract 22. I get negative 20. I take out a 2. You guys see my problem here. This isn't going to factor. There's nothing that multiplies to 10 that adds up to 11. Multiplies to negative 10. I can't put both. I can't put both x. This was supposed to be a 9. Now, how did I screw that up? All right, let me go. You know what I'm going to do? I do know what I made out the answers to be. So you know what I'm going to do? I'm going to show you a way to check these answers by using your calculator. So let me bust out my calculator. And let's see here. We're going to go to calculator. And I made the answers so the answers would be 10 and negative 1. So what I'm going to do, just showing you how to check your answers on these. I'm gonna take 10 because 10 was supposed to be one of my answers, and I'm gonna see if the problem was even written correctly. So 10 stow x. So I'm gonna use this as a means to just check the answers. All right. So now I'm gonna type in everything. So control division. So let's see, negative 3 divided by negative 3 all over x plus 5. Oops. X plus 2. Wait. Negative 3. Looking at the wrong. Oh, it's right above me. What am I doing? X plus 2. X plus 2. I was looking at my sheet here. Minus control division. 2x minus 5. I'm just checking to make sure that's right. So it's 2x minus 5. 2x minus 5 all over x minus 4. Now, if this turns out to be true, it means I clearly made a mistake someplace, and I hope you found it while we were going through. Well, that's not what I wanted. Equals. I think that should still work out. Should work out. Control division. 20x plus 2 all over x squared. You can't imagine how difficult these problems are sometimes to make them work out for you. Equals false. So it didn't work out properly. All right. You're going to have to give me 30 seconds to figure out what I was supposed to do there. Let me redo the problem real quick. I'm going to do it on my paper here. If you want to just fast forward a few minutes, I'll let you know. I'll wave at you when I got it ready to go. And then we'll start this problem over. Negative 3 over 12. I did this problem 4 different times. And I know I put the answer in here right. But I screwed something up, so let's see. Plus. By the way, the answers are going to turn out to be, I believe, 10 and negative 1, but we'll see. Let me make sure. Did I put those in right? 2x minus 2x. Minus 2x minus. Yeah, I'm so dumb sometimes. I don't know what's going on. So 2x minus 5, that's going to be 15. 20 minus 5 is 15 all over 6. So that's negative 3 over 12 plus. Why is it negative 3? I thought that was supposed to be 3. 30 over 12, which is 27 over 12. Now this denominator is going to be 100 and 100 minus 20 minus 8. That's 72. So 72. So multiplied by 6, 27 times 6. You guys have no idea what I'm doing, do you? And if you're still watching me, you're just watching this genius at work. 2 2, 4, 12, and 4 is 16. 162. 27 times 6. 162. So that should be 16x plus 2. Now I gotta make sure it works. So -3 over, well, I'll just do it with you. Let's just do it with you. We'll see if it works this time. You're watching me. I'm going to go through this rather quickly now. Hopefully this works. I believe what this one was supposed to be is, get rid of this, 16x. Why is there a minus there? Hold on a second. On my original, on your worksheet it says -20, and on mine it says, on the sheet it says 20x, on your sheet it says -20. I just want to verify that this does in fact work. I don't know what I'm doing. So -2x squared plus -2x plus 22 equals -20x plus 2. So 0 equals 2x squared minus 18x minus 20. 2x squared minus 9x. Are you kidding me? You know, all right. Son of a gun, this is a pain in the neck. All right, so let me show you what happened. I had the problem right. The problem's right on your sheet. Here's the problem. Sometimes when I print to OneNote, and I don't know if you guys have ever used OneNote, sometimes things misappear. That negative disappeared, which makes the entire problem wrong. Remember that -18 I told you I was supposed to have? I'm now going to get that -18. So this is x minus 4, x plus 2. I'm going to fly through this one, okay? So all the stuff I said before are going to work, and I apologize for having you guys sit through that. So if you remember correctly, if we can go back to here, I don't need that long of a line, but if you go back to here, I think we're at this point. We had -3 times x minus 4 plus -2x. Why am I drawing even a fraction line? I got myself, I'm so mad right now. Just because that stupid minus was there, I'm wasting your time and my time, and I really hate to waste your time. Actually, I hate to waste my time more. Just kidding. And then this would be x plus 2. And this is equal to -20x plus 2. The only thing I was missing was that silly negative, and you guys are probably sitting there going, why doesn't he have a negative? I have a negative. I don't understand why he doesn't have a negative. That's kind of crazy. So -3x plus 12. Let me get back to this. And this is going to be -2x squared plus x plus 10 equals -20x plus 2. Clean. I'm not going to really take my time to clean all this up. This going to the other side, so it's going to equal 2x squared. Move that over. Now this is -3x and positive x. That's -2x. When I add the 2x onto this side, I get -18x, and that was what I was looking for before. And then I got 22 on this side, and I'm going to subtract 22, and I get -20. And you'll see that this factors very nicely. Take out a 2. I'm left with x squared minus 9x minus 10. And now the factoring is quite simple. X minus 10, x plus 1. So my two answers are 10 and negative 1. And neither one of those are undefined because I can't have x equal negative 2, 4, and that's it. Negative 2 or 4. Can't equal. I am very sorry about that. That's kind of ridiculous. Let me make sure. I'm going to make sure from now on that the thing's printed out right. X over x plus 5, 9 over x minus 5, 50 over x squared. Okay, this one works out nice. All right, so my common denominator here should be pretty obvious. It's going to be x plus 5, x minus 5. I think I'm on the fat writing, aren't I? I feel like I'm on the fat writing. So I'm going to take each of these and multiply by x minus 5 and x plus 5. X plus 5, x minus 5. X plus 5, x minus 5. All right, on the left side, the x plus 5s cancel, and I'm left with x times x minus 5. And I haven't looked at it in a while, so I've been neglecting eye contact. So I'll just stare at you for a minute. Let's have a blinking contest. Let's see who wins. Tell me if you won my blinking contest. Who blinks first? I'm about to blink really seriously. Oh my gosh. Oh, I'm sure if you beat me, you must have beat me on that one. How many? Rewind it and have a blinking contest with me. I'll bet you beat me. All right. These x minus 5s are going to cancel. And I'm left with x plus 5 equals, see ya, wouldn't want to be ya, 50. So we finish. We keep going. We get x squared minus 5x plus 9x plus 45 equals 50. Bring everything to the left side, so I get x squared minus, plus 4x minus 5 equals 0. X plus 5, x minus 1. So my two answers are x equals negative 5 and x equals positive 1. I'll come over here and put my final solutions in my curly braces, and my final solutions are 1. Now, why not the negative 5? Well, because if I'd gone back to my original problem, I should have said x can't equal 5 or negative 5. There we go. Done with that. All right. See how this is put in and tell us that we're going to do it in a plus bi form here? That means you're not factoring this puppy. So let me write it out. This one will not be factorable. You will have to use the quadratic formula. And I know that most of you at this present time are just jumping up for joy. You're just so excited. Common denominator is x, so we're going to multiply everything through by x. Let me change to green. Get a little ho, ho, ho. Times x and times x. Okay, so I get 2x squared. Over here, the x's just cancel. So plus 3. Nothing cancels here, equals negative 2x. So I'm going to clean this up. I get 2x squared plus 2x plus 3 equals 0. Now, I can't use completing the square because if I divide by everything by 2, first of all, I have 3 halves, and that's a problem. Those of you trying to factor with decimals, please stop. Please stop. Seriously, I've never, ever once factored with decimals before, so those of you that are factoring with decimals, okay, that's just weird. So, A equals 2. B, and you know who you are, equals, well, 2. C equals 3. And D, which is the discriminant, is b squared minus 4ac. Make sure the problem was written down right. All right, looks like it's written down right. So it is x equals, those of you forgetting to put your x equals, I've been taking points off, negative b, negative 2 over 2 times a. Oops, we might want to put in what that actually is. Two times 2 plus or minus the square root of, oh, haven't done the discriminant yet. This is b squared is 4 minus 4 times 2 times 3. So that's 4 minus 24, which is negative 20. So negative 20 all over 2 times 2. Now, if I take the square root of negative 20 off to the side here, I know that's negative 4 times 5, which is 2i square roots of 5. And you guys are getting pretty good at that. So I'm going to replace this with 2i square roots of 5. Now I'm going to simplify it, and I'm going to give you a final answer. It's negative 1 over 2 plus or minus I square roots of 5 over 2, because these 2's cancel. And these 2's cancel. There's your answer, right there. All of its glory. All right, page 2 done. We're getting there. All right, so which points are restricted from the domain? Domain are the x values. Okay, so we're looking for the x values. I should have a highlighter. I should just highlight that because it looks so much sharper. I'm going to highlight in green. Domain. I'm looking for the domain. So I know that domain are the x values. So I'm going to say x is in a set of all reals such that x cannot equal that value, because I have a vertical asymptote there. And because I have a vertical asymptote there, I know x cannot equal 3. Ooh, I wish they were all that easy. Again, vertical asymptotes. Vertical. What values can x not be? Well, x cannot equal... Oh, it says find the vertical asymptotes. Well, the vertical asymptotes, I misread the question, I apologize. So the vertical asymptotes are what make the denominator equal to 0. Those will be the vertical asymptotes. So in this case, negative 3 would make them 0. So my vertical asymptote is x equals negative 3 and x equals 1. Now I should be able to come over to my calculator, type that in and see that. Let's see if I can do that. Go into calculator mode, and I'll do control division, x squared minus 9 all over parentheses x plus 3 x minus 1. Enter. Okay, so you'll see that your vertical asymptotes... Oh, I forgot. Sorry, kids. That's one thing I think we didn't talk about. I'm not going to put this on the test. Let me go back. Notice there's only one vertical asymptote here. It's at x equals 1. And I'll go back to show you why. And I should have showed you guys this while earlier. I actually had to ask the teacher whether or not we had to show this to you or not. You really can't talk about the vertical asymptotes until you have this factored. So this factors to x plus 3, x minus 3. Sorry, I completely forgot that this was part of some of what we have to do. X plus 3, x minus 1. Don't these cancel? Okay, so the only time I'm going to have a problem right here is when x equals 1. So that really, truly is my only vertical asymptote. I will not put that on the test. I think that's for something for later. But since we're there, let's talk about it on the next problem, because it comes up on the next problem as well. The numerator factors to x plus 2, x minus 2, all over x plus 2, x plus 9. I'm really sorry about that, guys. I really am. I had a brain fart because I'd forgotten that. I thought we didn't have to teach that to you, and then I'd asked a little bit later, and they're like, yeah, we probably are supposed to. I don't think we see it ever on the Regents exam, so it's nothing you'll have to worry about, but these things actually cancel, so my one vertical asymptote is going to be x equals negative 9. So it's not a big deal. Over here, the horizontal asymptote. Well, if you remember correctly, this goes back to the straight up rational equations one, the one that looks like this in this quadrant or this quadrant. And then what does the plus 2 mean? Well, that means this whole thing is going to move left, right, 2. Probably shouldn't do things when I'm tired. We're going to move right 2, but we're not moving up or down at all. And the other thing we talked about also is the fact that no way this thing would ever be equal to 0, because the only time a fraction will ever equal 0 is when the when the numerator is equal to 0. And since we can't make the numerator ever equal to 0, I know that the y value will never equal 0. And so my horizontal asymptote, which are y lines, is y equals 0. In this particular problem, if you remember correctly, here we go. This one is going to give us our vertical asymptote. So we're going to have a vertical asymptote of x equals 1. But if you remember correctly, we're also going to go down to, and we'll also have a horizontal asymptote of y equals -2. And that's mostly what I want you to know from all this. All right, solving rational inequalities. So if you remember correctly, what we had to do first is find our critical numbers. Critical numbers are what makes the denominator equal 0 and what makes the numerator equal to 0. So in this case, the numerator equal to 0 is 4, and the denominator is -7 and +9. So we're going to draw a number line, put these numbers on there, -7, 4, and 9. So we're going to break this into 4 zones, and we have to test all 4 zones. So if I test out here negative, the numerator would be negative, that would be negative, and that would be negative. That means I'd have 3 negatives. Negative, negative, negative makes a negative. Make sure this problem is written right. I changed these up. All right, so, I'm sorry, I changed the problems up. In this range, I'm going to plug in 0. Well, if I plug in 0, the numerator is negative. This would be negative. So I'd have, if I want to think about it this way, I'd have negative in the numerator, positive here, and negative here. Well, 2 negatives make a positive. And this one here, if I picked like 5, in the numerator, I would have a positive. In the denominator, I'd have a positive and a negative. Well, that's negative. And over here, everything's positive. Positive, positive, positive. So this is all positive. And I'm looking for when it's positive. So if I want to graph it, -7, -4, and 9. Where is it positive? Well, it's positive between here and here and here and to infinity. Now, if I want to write that in interval notation, then that is from -7 to -4, union 9 to infinity. All right, critical numbers here. -2. Oops, got a factor. See, something's missing here. Plus 4x plus 12. See, I don't end up with a problem again. So x plus 6. X minus 2. I really let that throw me. So -2, +2, and -6. Those are my critical numbers. That'll break it up into 4 zones. -6, -2, and 2. So I'm just going to do this because there's 3 things. And we'll grab a different color. Okay, so there's 3 things, and we're going to plug in a big old negative number. So this would be negative, this would be negative, and this would be negative. 3 negatives makes a negative. This would be, let's see, negative. Let's try -3. This would be negative. This would be positive, and this would be negative. So that's positive because 2 negatives make a positive. If I picked in 0, this would be positive. This would be positive, and this would be negative. So that would be negative. And a big positive, 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 and everything's positive. And I want where, well, once again, I want where it's positive. So if I do my number line, -6, -2, and 2. Oops. So between -6 and 2 it's positive, and from 2 above also positive. All right, so I think you all see that your critical numbers here are going to be 0, -5, and 5. because this factors to x plus 5, x minus 5. All right, so negative 5, 0, 5. My three critical numbers, there they are. I'm going to avoid the parentheses. They drive me nuts. Too much work. All right, so way down here, if I plug in a negative 100, negative, 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 3 negatives make a negative. Negative, if I plug in negative 2, negative, positive, negative, 2 negatives make a positive. Negative, oh, now we're positive. So that's positive, that's negative, that's negative. Positive, 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 that's positive. So I want where it's negative. So I want negative 5, 0, and 5. So I want less than negative 5 because that's negative. And I want between 0 and 5. If I do that in interval notation, which I'm running out of space here, that's from negative infinity all the way up to negative 5. Or, did I do ors up here? I didn't do this one. I'm going to come back to that one. Or 0 to 5. And this one up here, this one should have been negative 6, comma, negative 2, or 2 to infinity. And did I do this one? I did that one. Now this last one's a little bit trickier because there's actually 4 critical numbers. This is, something is missing here. This is missing a 5. I can't believe how many numbers are dropping out. All right, so x minus 9, x plus, I think my battery's dying in my pen. X times x plus 2. It's not writing very well. Okay, so my 3 critical numbers are going to be 9, negative 5, 0, and negative 2. Wow, lots of critical numbers. That's actually going to break it up into 5 zones. Negative 5, negative 2, 0, and 9. So we got to be careful here. All right, so if I pick negative big, that's going to be negative, negative, over negative, negative, that's positive. If I pick like negative 4, let me show you up here. If I pick negative 4, this would be negative, this would be positive, this would be negative, and this would be negative. So I got negative, 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 positive. So that's negative, positive, negative, negative. That's odd number of negatives. That's negative. This was positive. And if I pick negative 1, then this one becomes positive. So now I have negative, positive, negative, positive, and that's positive. And if I pick like 5, this is still negative. Top left is negative. This is positive. This is positive. Let me go back to this one. I think I actually made a mistake here. Hold on a second. I want to go back to this one right here, and I want to clear out some of this stuff, and I want to show you something. Let me go back here. This was x minus 9, and this was, that's right. So if I pick a number like 5, I probably shouldn't write that in there, but if let's say I pick 5 as my test number, I'm going to test 5. If I put in 5 here, we should be doing this in red. If I put in 5 here, 5 minus 9 is negative. 5 plus 5 is positive. 5 by itself for this one is just positive. And, oh, I'm sorry. I'm testing. Okay, I'm going to test this one too. And I put in 5 here for this one. That's also positive. So that's positive, 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 negative. That's negative. So anywhere in here will be negative. Now let me go back and test this one a little bit. Let me go erase this stuff. Okay, now we're going to try -1. So -1 in here, that makes that negative. -1 in here, that makes that positive. -1 here, that's just negative. And -1 here, that's just negative. Well, 3 negatives make a negative. And let me just make sure I got this one right. If I plugged in -3, that's negative. Got that one right. Plug in -3 here, I got that one right. And if I plug in -3 here, that's negative. And if I plug in -3 here, oh, if I plug in -3 here, it's positive. So that's positive. So 3 negatives make it, so negative, 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 negative. So all this is negative. Let me pick, and I'm picking up positive 100. These are all be positives up here. So this is positive. And I want where it's positive. So it's positive actually from -5 down and from 9 up. All right, moving on. Last 3 problems. All right, if you remember, varies inversely, and I'm going to read it. Let me see if I can make this a little bit smaller. Varies inversely with the rectangles. So this is going to just be, in this case, where am I? Length times width equals length times width. So in this case, length of 12 times the width of 6 is equal to the length of 9 times the width of, well, I don't know. This is 72 equals 9W, so W equals 8. Done. These are easy. When the air is pumped into an automobile, the pressure is inversely proportional to the volume. So again, here we go. Pressure times volume equals pressure times volume. If the pressure is 35 and the volume is 120, what is the pressure in pounds when the volume is 140? So let me bust out the calculator because I don't really feel like doing that in my head. So 35 times 120 equals 4,200. So over here we'll do 4,200 equals 140 times P, and then this math's pretty easy. 140. Let me get rid of those zeros. And this should be 30. I think it's 30. Divided by 140 equals 30. Yeah, that's what I thought. Okay, and does that make sense? Does it really make sense? Let's see. The pressure went, the volume went up, so the pressure had to go down. Makes sense. A pulley that has a diameter of 8 inches is belted to a pulley that has a diameter of 12 inches. The 8-inch diameter pulley is running at 1548 revolutions per minute. If the speed of the pulley varies inversely to the diameters, how many revolutions? So, diameter times revolutions equals diameter times revolutions. So 8 times 1548 is equal to 12 times revolutions. Now, since the diameter went up, the revolution should go down. And let me come down to my calculator. 8 times 1548, enter. And then we're going to end up dividing by 12, so I might as well do that now. So 12384. 12384 equals 12R. Divide by 12. I think it R equals, I don't remember what that was, 1032. 1032. And notice the number of revolutions came down. All right, so I made a couple of mistakes. I hope I fixed them. Hopefully you guys learned from this. Hopefully you'll do good. Hopefully you all viewed this, and hopefully you all do good on Friday's test. And I apologize. Maybe I'll see if I can get some candy canes or something for you. Sugar you all up and then send you off to the next class. All right, guys. Good luck. Thanks for joining me tonight. And this is Mr. Krause signing off from my basement. Peace out.